Welcome to our tutorial of configuring CAN port in eStorm-C2 to receive and transport CAN signals by consuming CAN database using Flint System Configurator. Flint System Configurator is a handy tool that enables low-code development of embedded firmware. Together with RAPDISEA, it is possible to develop software-defined embedded systems without writing complex code at all. In this tutorial, let us learn how to leverage the RAPDISEA automotive in-vehicle networking stack and configure the system to handle CAN data. We will create a simple example where the eStorm-C2 instrument cluster kit will be used to receive and transmit IVN messages. The automotive industry uses the CAN DBC file to specify the messages transmitted in the network. An acronym for CAN database, the DBC is a text file that contains information for decoding raw CAN bus data to physical values. In this example, let us assume that the instrument cluster we are designing receives the following information over CAN: vehicle speed in km per hour from a value of 0 to 20, engine speed in RPM from a value of 0 to 11, odometer in meters from a value of 0 to 200, and fuel level in percentage from 0 to 50. Assuming these are received over two different messages, the corresponding section in the DBC file will look like this. Here, the message ID 1000 has fuel level, and ODO, message ID 2000 has vehicle and engine speed. The cluster may transmit illumination dimming level to BCM in percentage from 0 to 50. The section corresponding to this looks like this in the DBC file, and the message ID 3000. Let us now use Flint's System Configurator to consume this DBC file for a cluster running on Embien's eStorm-C2 platform. Create a Flint project with project type RAPDISEA with Sparklet and board Embien eStorm-C2. Add your vehicle DBC to the resource folder. Here we use the simple DBC file demo.dbc. In the data folder, locate default data EFD file. Add the required data info to it. Right-click the RAPDISEA folder and create a new Sparklet application module with application type DBC and name it vehicle rx.efa. And open it in DBC Editor. In DBC file field, browse the added demo.dbc. Click the Read button. The table will be filled with the CAN signals and their details. Double-click the signal vehicle speed, need to be received by the cluster. DBC Signal Config Editor is opened. Check the Enable Export checkbox and map the respective data info created, and click OK. Repeat the same for all required signals. Repeat the same steps to create vehicle tx.efa and map the data info for the signals, which are to be transmitted by the cluster. Right-click the RAPDISEA folder and create a Sparklet interface with interface type CAN and name it as canivn.efi. Enter the port number, baud rate, number of RX, number of TX, and number of RX filter as per the platform specifications. Enable the applications DBC-RX and DBC-TX. Map the vehicle rx.efa and vehicle tx.efa to DBC-RX and DBC-TX respectively. Now open the eStorm-C2.efm in Module Editor. From Toolbox, drag and drop the CAN port from the driver modules to the CAN TX and RX holders. Now drag and drop the CAN DBC from application modules to the application holder in the CAN port. Now double-click the CAN DBC block in Property tab in right bottom corner. Map the created canivn.efi file to the DBC app field. Let us map the data info to the respective widgets of the cluster screen created already. Save and click Export All button. The binary output is generated. By programming the output on the eStorm-C2, the cluster changes as per the input provided over the CAN bus. Let us see this output in action in the next video integrated with Flint Visual Programmer and UI Designer. Thank you.